Hey, welcome back to the Queen City Guitar Shop. So today I have a top, it's ready to start voicing, but before I got into that, I thought it would be nice to talk a little bit about the process of prepping and gluing braces on, and also a little bit about what goes into considerations in voicing a top, and bracing a top, sort of a pre-voicing, voicing. Now I'm indebted to many teachers, both in like formal school settings and reading articles and watching videos on YouTube and Luthier's websites, who have taught me a lot about what goes into guitar sound production and some ideas about getting a good sound out of a guitar and volume out of a guitar. And I think it's important to have a lot of viewpoints in regards to that. And this is sort of where I am at in thinking about that. Every time I get to this stage of a guitar, I tend to step back, think about what I'm doing, think about the reasons that I'm doing it, and just try and see if I can glean any new insights. So this represents where I'm at for this particular guitar. Now when we think about a guitar top, if it was completely lacking in braces, but we'd still glued it on to the sides with the intention of playing the guitar like it was braced. I think we would notice that the structure is a little bit backwards. We would have the stiffest portion of the guitar top would actually be around the rims where it's glued solidly to the linings, and as we move to the center where the bridge is, we would end up with a much looser, that portion of the top would be much looser, and it would have all that string tension. It would want to flop around a little bit. I don't think you would get a good sound. And there's also the problem, of course, of the fact that the strings are anchored to the bridge and exerting a pretty substantial force on the top. And if you can imagine, because of how they're anchored to the top and then they rise up to the saddle, that they create a real dramatic lever effect. And we brace the guitar specifically to resist this rotational bridge force. And of course, obviously, to arrive at a pleasant sound. So if you look at this top, the braces are totally uncarved. It's probably the most noticeable thing that I've glued these on, all very tall, very thick, very rectangular. I do this on purpose. I think that I want to be able to listen to how the top changes as I shape the braces from this completely unshaped place. I think that I feel as a hand builder that I have time to give this amount of attention, and I feel like I can learn a lot on every top as I bring it down into the shape. I have a basic idea based on previous guitars and records of bracing on those guitars of where I want this to end up. But of course every piece of wood is different, and I don't want to go into this with too many assumptions. So that's part of it. It's also a lot easier to glue the rectangular braces down. I think you get a better glue joint. It's just simply a better setup. I use a Go Bar deck, and for that it's just a much better setup for doing the brace gluing. You also notice the sound hole is surrounded by this ring brace. A more traditional method of doing bracing in this area would be a couple of strips of spruce. I do the ring brace for a few reasons. Substantially, you have a very thin piece of wood in a hole, and there's always the risk of splitting. And the bracing around the sound hole in conjunction with the rosette is a means of controlling that and strengthening this area. Now this brace, the grain runs in the same direction as the top, so you might say that it is not going to be as effective as a cross-grain brace might be in resisting splitting, but I think it more than doubles the top thickness, and in conjunction with the rosette, I think it provides a pretty substantial protection against splitting. It also has the advantage of working with the X brace to carry the load of the strings in the direction that the strings are traveling. I also, when I finish this guitar, will have rounded this very greatly thickened sound hole off, and I think it's aesthetically pleasing. And I think that that rounding, I at least hope that that rounding will help to smooth the airflow in and out of the guitar. When the guitar is resonating, there's of course air moving both in and out, and that creates some of the sound of the guitar. There's sound, of course, resonating directly off the top, and then there's a sort of resonant column of air that moves in and out to create sound waves that people listening and the player will perceive. And the third thing is that I have this rather odd bridge patch. And I arrived at this, if we consider how a traditional guitar is set up, the bridge is of course sitting over an area of the top with basically no braces under it, and it's got this tremendous rotational force on it. It generally intersects the X braces a little bit, and that helps to transfer the load through the X's forward into the sides and the upper bout. And the traditional bridge patch is normally a cross-grain hardwood patch that sits here. If you imagine, probably most of us have seen old, cheap ladder brace steel string guitars, and they often have a very pronounced deformation because of how they're braced. And you see in front of the bridge the top getting pressed down into the back. So the X brace essentially supports that load. And they'll also often have a belly where the bridge is lifting, and the bridge will be rotated like this, and it'll be lifting, and because of how it's glued around the edges, this whole section will dome out and the bridge will adopt a curve. And so that cross-grain patch is basically preventing or inhibiting this area from adopting that curvature. However, when I was building the prototype for the shape that this guitar will be, the RBO or RB-OT, I'm not really big on the nomenclature, it's just a roundabout size O, sort of parlor guitar. I was trying to make a 12th fret, and it was really, there's just not a lot of crossover on the X brace and the bridge, and so I was thinking more heavily about how this section of the top is supported, and thinking about on a scallop brace guitar how you're basically, the bridge is transferring force to an area of the X braces that I've specifically weakened in scalloping. And I thought it would make a lot more sense if we could transfer force forward to the X brace in its strongest point and then outward around the sound hole. And at the same time, it seems like the tone bars are much better suited to resisting curvature than this small plate. And the farther you can extend that rotational force and that stress on the top outward, the more of the top is being activated to resist it. And of course, wood is stiffest in the direction of the grain. And so I started thinking that a parallel grain patch would allow you to transfer that force directly forward and strengthen the top in this area that's unbraced between the bridge and the X brace, and also do the same from the back of the bridge to the tone bar. And you would be able to spread that stress from the strings over a larger area into braces that are more effective at dealing with it. And by making that patch spruce, even though it's a little bigger than a traditional bridge patch, it still should end up lighter than a traditional bridge patch. And there's still, of course, one strange thing about this, in that there's a small rectangle of hardwood. The other use of a hardwood bridge patch is because you have the pinholes coming through and the strings pressed into those against the top, and those string ends are going to tend to bite into the wood and they'll just chew up the spruce. So you really need hardwood to ensure that that doesn't happen. So I put a small rectangular patch of hardwood in. It also, being cross-grained like a traditional patch helps to give a little limit to the amount of curvature that the bridge is willing to undertake under the pins directly where the string force is exerted. But it's primarily there for the purpose of keeping the top from getting chewed up by the strings. It is actually inlaid, not all the way through, but partially through the spruce bridge patch, which also aids in another problem that sometimes appears in a traditional bridge patch, where being weakened by the pinholes and having that string force exerted on it, sometimes it'll split. The glue is just not quite strong enough to hold it to the top and together, and it'll split. But in this inlaid design, there's not only the glue holding it down and together, but it also is registered against a shoulder very tightly all the way around, and so it has a physical limitation to its ability to split. So the bridge patch is working with the braces, of course, to counteract that tendency of the top alone to be backwards in its stiffness, but the top is also itself a brace, and so I'd just like to note that when I flip it over, you may have noticed all of these numbers, and that is specific thicknesses in different parts of the top, and I have actually differentially thicknessed the top of this guitar and all of my guitars for the last couple of years to make the center thicker and the edges around the lining thinner, in an attempt to loosen up the edge of the top around the lining. It's a common thing in classical guitars. I think it works really well in steel strings as well. So before we actually start carving the braces, that is a little bit about how I think about what I'm doing in the bracing and the function of it and how each element of the design contributes to the sound. Now I'd like to talk a little bit about how we get from the blank top with no braces on, and of course the braces not cut out, how we get from that point to this point where we have them all glued on and we're ready to start carving away. I like to source my Sitka spruce from the lumber yard. It comes in big slabs generally, and I will then resaw it down into an appropriate thickness board and partition that board out into pieces of an appropriate size for the braces that I need for a guitar, whatever guitar I'm working on. Once we have a board that's been milled to the correct thickness and cut to the correct length, you're going to want to joint the edge that you want to start cutting braces from. It's important to orient that face of the jointed edge with the vertical grain that you can see in the end grain of the board, so that it's parallel with the vertical grain, and also so that the jointed edge is in line with the grain that runs across the face down the length of the board. That doesn't have to be 100% perfect. Often you'll look at a board and think that those grain lines look really straight, and then when you start planing you realize they're not completely straight, but it's important to get it really close. So then once you've got a jointed edge, you can simply scribe a line around the board, outlining the brace that you want to cut, a couple millimeters wider than what you'd like the brace to end up being. I normally go about 2 millimeters, and then I have an ample amount of room for error. And just cut the brace out, and when you have the brace cut out, you joint the edge again, go through all the steps, paying attention to the grain in exactly the same way. Sometimes you have to adjust the face as the grain moves through the board, and cut out the next brace. Once I have all the braces cut out, I'm going to end up with these blanks with one smooth plain side and one rough sawn side, and they're going to be a little bit oversized, and I'm going to need to thickness them down to the thicknesses I desire for each individual brace. So to do that, I'm going to set up a board in my vise to act as a stop. I'm going to get out calipers and a block plane, and I'm simply going to plane them down carefully to the desired thickness. I'm going to pay a lot of attention while I do this to the thickness across the entire brace. I often find that the portion of the brace up against the stop will plane down faster, and if I've done a good job of following the face grain on the brace, then it's no big deal to flip the brace around and plane from the other direction to even that out. So I'm just going to plane through every brace until all of them are exactly the thickness that I want them to be. So we have braces cut out of blocks and thicknessed up. The next step is going to be to roughly put in the radius that they're going to be braced against for the top and the back. So to do that, I have got radius blocks made for both the top and the back radius. I use these for both drawing on the radius on the braces, and also just to, when I sand them, help keep the brace standing upright so the angles don't get off. So you want to mark a rough center line on the brace, and simply draw the radius onto one side. Trying to be pretty even. Now, because we were chasing the vertical grain through the block, we end up with some braces with sort of an angled surface on the top and bottom, and it's important to draw the first line on this side, the shorter side, so that when we transfer it over, everything will work out. And transfer it, and just set a square up, line it up with this edge of this line, make a mark on this side, do the same thing on this side, line up with the edge of the line you just drew and carry it over, and then we just line our template up with those two lines intersecting in the middle. And draw the radius on the other side. And from there we move to this setup. I've just got a cam clamp clamped with a board just so I don't put a big ding into the clamp to the top of my bench, and it's spaced so that the brace will run basically to the edge of the table. So I can do half the brace, plane half the brace down, and then pop it out, and in just a second put it back in and do the other half of the brace. I'm going to be checking constantly against the dish, and then when that brace is done I can switch to the next one and the next one, and I only have to reset this up when I change brace lengths. Sanding and planing, planing and sanding. Sanding and planing, planing, sanding and planing, planing, sanding and planing, planing, sanding and planing, planing and sanding. Before you know it, all of the braces are done. So with the braces all radiused, we're just about ready to glue them onto the top. But first, we need to get the top itself to this state. Namely, I want to have the sound hole ring glued on, and the sound hole cut out, and the bridge patch glued on. And so to do that, the first step is of course to joint and glue together the X brace. And then we're going to need to locate where all of the braces are going to go on the top. Now, at this point, as I said, the sound hole is not cut out, and so the top still has a locating pin in it. It's the pin that my circle cutter spins around on. The template also has a similar locating pin. So I can register the two together using that pin and mark out the braces. My template, all of the brace center lines I'm able to mark. And so I'm going to go ahead and do that. And then at that point, I can locate the X brace on the top and clamp it in the go bar deck, just dry clamped. And I can trace the edges of the X brace just with a pencil and pull that off. And then the sound hole brace is actually just a disc with a hole for the locating pin in it at this point as well. So I can slip it onto the top and I can mark it where it intersects with the X brace. Pull it off, plane it down to those lines, and then it's as simple as dry clamping the X brace again, and slipping the sound hole brace onto the top with a locating pin, registering it with that and the X braces to glue on. And then after a minute or so with the glue and clamped onto a caul, which also has the locating pin drilled into it so I can slip it over, I can just pull the X braces off and clean up the glue squeeze out and wait for it to dry. And then when it's dry, I can cut the sound hole out, and that's almost ready to go. Now I locate the bridge patch in a pretty similar way. I can dry clamp the X brace exactly where I want it, and dry clamp the first tone bar, and then the only difference is that I'm going to put a piece of tracing paper underneath the X brace and the tone bar in that area where the bridge patch is going to go, and I'm going to trace the outline of the bridge patch using those three braces, and then complete it just with a line that creates a nice delta shape, whatever size that I feel is appropriate. And at this point I'm also going to mark off where I want the pin plate, the hardwood pin plate that I'm going to inlay, and then I can take everything out of the go bar deck and roughly cut that piece of paper down to size and tape it to the sheet of Sitka that I have prepared to be the bridge patch. And I'm first going to scribe around the pin plate rectangle just to make a mark for where I'm going to want to inlay that with the knife, and then I'm going to put aside the piece of paper that I get from that for later. And then in a very similar way, I'm going to go around the border of the bridge patch that I marked out, cutting through the paper and scribing a line to cut with a knife to arrive at the bridge patch exactly the size that I want it. In this clip, I'm actually cutting out the shoulders for the pin plate inlay, but cutting out the bridge patch is very similar. I am going to use a couple of single bevel knives that I have, and I simply cut the shoulder with the single bevel knife, obviously the unbeveled side on the side of the shoulder, and then relieve the cut and cut it again and relieve the cut, and I keep doing that until I've worked through the whole thickness of the bridge patch, and that leaves a very clean and crisp shoulder with no tear out. And then I can dry clamp the X brace back to the top and use it to accurately position and glue that bridge patch down. I use some cauls that are just basically braces, pieces cut off from braces that are radiused, and I can use them to get a good pressure on the from the go bar deck onto that flat sheet of spruce, and then pull the X brace off and clamp the glue squeeze out and let it dry. When it's dry, I can feather it front and back and side to side down to a sort of tapered thickness, and then I can go ahead and do what I'm doing in this clip, which is to cut out that pin plate inlay. Again, cutting the shoulders with the knives. It's very important at this point because a chisel could easily split the top. I only use chisels in this inlay to remove the material from the cavity, and to flatten the bottom of the inlay cavity. In order to prep the pin plate that will go into this inlaid cavity, I'll actually take that piece of tracing paper that was cut out earlier, the rectangular piece that I set aside, and I'll glue it to the material that I want to use for the pin plate, and then I will simply use it as a guide to cut that out and to plane it down to size, and that way I can arrive at a tight fit pretty quickly without a lot of fuss. And then once I have a tight fit, I can just glue it right in, again in the go bar deck, using the same cauls. And then the last thing to do before gluing the braces down is to simply round off that sound hole brace ring, for which I'm going to use the same knives that I've been using to roughly round it off, and then I'm going to sandpaper it smooth. And that is my basic process, preparing brace stock into brace blanks and prepping the top for glue up. A lot of time is spent on hand-built guitars discussing actually carving the braces and voicing the top through that process, but there's also a great deal of care that goes into preparing the brace stock, prepping the braces themselves to be ideal both for structural and tonal purposes, and in preparing the top. And that is a little bit about how I do that. Today I am recording in Oakland under the shelter-in-place order that went in effect a few days ago, and subsequently I've had a little bit more time to focus on guitar work, and I anticipate having more time in the future to focus on guitar work, and also more time to be making these videos. Today I actually just finished carving the braces on this top, and I anticipate within the next week having a new video up discussing the considerations that go into the process of voicing the guitar once the braces are glued on, and sort of how I go about voicing my guitars to get the sound that I want. So I hope you'll tune back in soon to check that out. I hope that you are staying healthy, and as always, you can follow the link in the description to my website if you're interested in learning a little bit more about building guitars, or if you'd just like to see some more of my work. I hope to see you next time. Thanks!